The electrical code does not mandate that the point of attachment for an overhead service must be below the weatherhead instead of above it. The National Electrical Code, or NEC, offers guidelines and regulations concerning overhead service installations, but the specific vertical positioning of the attachment point relative to the weatherhead is not explicitly defined in the way the question suggests. To understand the requirements fully, firstly, one needs to consider what the weatherhead's purpose is, and secondly, examine the code sections that pertain to service drops and attachments. The weatherhead, also called a service head, serves to protect the service conductors from the elements, namely rain and snow, preventing water from entering the service conduit and potentially causing electrical hazards. It's designed with drip loops that allow water to run off without entering the enclosure. The location of the weatherhead is crucial for maintaining a dry and safe service entrance. Several factors influence the placement and requirements for the point of attachment of an overhead service. These include clearance from ground level, clearance from building openings like windows and doors, and the structural integrity of the building to support the service conductors. NEC Section 230.9 addresses clearance from building openings, stipulating that service conductors should have sufficient clearance to prevent accidental contact and ensure safety. The specific clearance requirements depend on the voltage of the service conductors. For example, a 120/240 volt service typically requires a minimum clearance of 3 feet from windows, doors, porches, fire escapes, or similar locations. This clearance is intended to prevent contact with individuals or objects that might be near these openings. NEC Section 230.24 provides guidelines on minimum clearance of service drops over areas accessible to pedestrians or vehicular traffic. These clearances vary based on voltage levels and the type of area the conductors are crossing. For instance, service drops over residential driveways might require a clearance of at least 12 feet, while those over public streets could require 18 feet or more. These clearances are crucial for preventing contact with vehicles or pedestrians. The code emphasizes that service conductors must be securely attached to the building or other structure. The point of attachment must be capable of withstanding the mechanical stresses imposed by the weight of the conductors, wind, and ice. The NEC does not dictate whether the attachment point should be above or below the weatherhead, but it does require that the installation be mechanically sound and compliant with clearance requirements. Local codes and utility company regulations often supplement the NEC, providing additional requirements or clarification on specific installation practices. These local rules can vary significantly from one jurisdiction to another, so consulting with the local authority having jurisdiction, or OJ, is essential. The AHA is typically a local building inspector or electrical inspector who enforces the electrical code and ensures that installations comply with all applicable regulations. Utility companies also have specific requirements for service connections, including the type and size of conductors, the location of the meter, and the grounding system. These requirements are designed to ensure the safe and reliable delivery of electricity to the customer. It is common practice to install the point of attachment above the weatherhead. This configuration allows the service conductors to slope downwards towards the weatherhead, facilitating water runoff and preventing moisture from entering the service conduit. However, depending on the building's architecture, available space, and other constraints, the attachment point could be located below the weatherhead, provided that the installation meets all applicable clearance and mechanical strength requirements. When installing an overhead service, firstly, safety is paramount. Working with electricity can be hazardous, and only qualified individuals should perform electrical work. Secondly, always energize the service conductors before making any connections or modifications. Thirdly, use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, to minimize the risk of electric shock or injury. Moreover, it is important to use the correct materials and methods for the installation. Use listed or labeled equipment that is suitable for the intended purpose. Ensure that all connections are tight and secure, and that the conductors are properly supported to prevent strain on the terminals. Proper grounding is another critical aspect of service installations. The grounding system provides a path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to trip and de-energize the circuit. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode conductor connects the grounding electrode to the service equipment, ensuring a low impedance path for fault current. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. Bonding is also essential for electrical safety. Bonding involves connecting all non-current carrying metal parts of the electrical system, such as metal conduits, enclosures, and equipment frames, to the grounding system. This creates an equipotential plane, minimizing the voltage difference between metal parts and reducing the risk of electric shock. The bonding jumpers must be sized according to NEC Table 250.102 cone, based on the size of the service entrance conductors. Overcurrent protection is another critical aspect of service installations. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. These devices are sized to protect the conductors from overheating and causing a fire. The size of the overcurrent protection device is determined by the ampacity of the conductors, as specified in NEC Table 310.16. The NEC also requires that service conductors be protected from physical damage. This can be achieved by using rigid metal conduit, intermediate metal conduit, or other approved raceways. The raceways must be securely supported and installed in accordance with the NEC requirements. In areas where the service conductors are exposed to physical damage, such as near roadways or in industrial environments, additional protection may be required. Surge protection is also becoming increasingly important in modern electrical systems. Surge protective devices, or SPDs, are designed to protect sensitive electronic equipment from voltage surges caused by lightning strikes or other transient events. SPD are typically installed at the service entrance to protect the entire electrical system. The NEC requires surge protection for dwelling units and recommends it for other types of occupancies. The selection of an SPD depends on the voltage and current rating of the service, as well as the level of protection required. The NEC provides detailed requirements for the installation of SPD in Section 230.67. The code does not state that the point of attachment must be below the weatherhead, but local codes might. It is very important to always adhere to the code or the requirements given by the utility,